In this video we're going to be looking at the differentials of the 6 trig ratios. The first two, sin x and cos x, you don't need to know the proof. You'll be deriving them in class, but for now I'm just going to put down the results of them. So if y is sin x, then dy by dx is cos x. And if y is cos x, then dy by dx is minus sin x. Okay, so those two results you need to learn. A way I think is nice of remembering them is if you start with sin x and you differentiate that, you get cos x. If you differentiate cos x, you get minus sin x. Then if you differentiate minus sin x, you'll get minus cosine x. And then minus cosine x will take you back to sin x. So going round in that direction, you get the differentials. Obviously useful later on. If you go back the other way, then you'll get the integrals. So the integral of minus sin x will be cos x, etc. Okay, so the next one we're going to look at is tan x. So we know from C2 that tan x can be written as sin x over cos x. So we're going to use the quotient rule with that. So we're going to make the sin x u and the cos x v. So another way of writing du by dx is u dashed. So if we differentiate sin x, the top of the function, we get cos x. And if we differentiate cos x, we get minus sin x. So we're going to use those in the quotient rule. So dy by dx is bottom v times du by dx, that's cos squared x, cos x times cos x, and then minus the top of the fraction u times dv by dx, that's minus sine squared x. So the two minuses will cancel out and we'll get sine squared x. And then it's all over v squared, or the bottom squared, which in this case will be cos squared x. Now, I hope you recognise the top of the fraction comes to 1, another of your C2 identities. So we've got 1 over cos squared x, or sec squared x. So the differential of tan x is sec squared x. Okay, so for the next one, sec x, we can write that as 1 over cos x. We could use the quotient rule again there, but I'm going to write it as cos x to the minus 1 and use the chain rule. Okay, so dy by dx will be minus 1 cos x to the minus 2, and then multiplied by the bit inside the brackets differentiated, so multiplied by minus sin x. Okay, so the minuses are going to cancel out. Top of the fraction we've got sin x, and the bottom of the fraction, because it's cos x to the minus 2, so we've got cos squared x. Okay, now we could leave it like that. That would be an answer to the differential of sec x, but a neater way of writing it is to split it into two fractions. So if we write it as sin x over cos x multiplied by 1 over cos x, then we get the result tan x sec x, which is how it's most normally known. So differential of sec x is tan x sec x. Okay, so two left. So we're going to do cosec x in a similar way. So if we write that as sin x to the minus 1 and use the chain rule, so we'd have dy by dx is going to be minus sin x to the minus 2 multiplied by the differential of sin x, which is cos x. Okay, so the minus cos x on the top of the fraction and sine squared x on the bottom. Again, split it into two fractions. We've got minus cos x over sine x multiplied by 1 over sine x. And that gives us minus cot x cosec x. So the differential of cosec x is minus cot x cosec x. Last one, so we're going to do this in a similar way to tan. So we're going to write cot x as cos x over sin x and use the quotient rule. So that's our u, that's our v. U dash this time will be minus sin x and v dashed will be cos x. So dy by dx is going to be the bottom, so v times u dash, so that's minus sine squared x, minus the top of the fraction times the differential of the bottom, so that's cos squared x, all over the bottom of the fraction squared, so that's sine squared x. So this time we've got minus sine squared x minus cos squared x, which comes to minus 1 over sine squared x. Okay, so we can write that as minus cosec squared x. So just to put all of these in a table, there's a summary and you need to learn them, so you need to know all of these. You also need to know how to derive the ones that we've just shown, so from tan x to sec x you need to be able to follow those proofs just using the results of sin x and cos x. So just put them in. So differential of, you might want to try and fill these in from, see if you can remember any of them already. That might be useful, but let's just go through. So the differential of sin x is cos x. The differential of cos x is minus sin x. The differential of tan x is sec squared x. Differential of sec x is sec x tan x. And the differential of cosec is minus cosec x cot x. And the differential of cot x is minus cosec squared x. Okay, so I don't know if it's useful, but you might think the ones, the ratios cos x, cosec and cot that begin with c and the negative ones, that might be a good way to remember which ones are which. Okay. Now that we have these results, we can obviously use them in the chain rule, quotient rule and product rule. So for example, if we wanted to find the differential of, let's just do a simple one, cosec of 3x, for example, we know that the differential of cosec is minus cosec x cot x, so that would be minus cosec 3x cot 3x multiplied by the differential of 3x, so with a 3 there, etc. You'll be doing lots of the practice of these in class.